Hi everyone and welcome back to my channel A in Economist. So in the previous video we have talked about what is bivariate Granger causality and we have understood what is the testing process in details step by step. But that was the theory portion and I told you that I will be taking up a numerical example to show you how you actually do it in the real life context. So here I am. This video is dedicated for that numerical example only, right? So if you remember in the previous video, I have taken up the same two economic variables, RT and pi t. RT is the interest rate and pi t is the inflation rate. And we wanted to know that if RT Granger causes pi t or not. So see here, test, we want to test statistically if RT Granger causes pi t or not, and that is what we will do in today's video, right? So I have taken a sample data and I will show you step by step how you can use that sample data to answer these kind of questions. So let us quickly go into that. So first step is that we will assume that this RT and pi t, RT pi t, they follow a var1 system. They follow a var1 system for our simplicity. For the simplicity of the example, you can take any value var p in general. Here for simplicity, I am taking p equals to 1, right? So RT and pi t, they follow var1 structure. And we want to know whether RT Granger causes pi t or not. So firstly, understand what is the dependent variable and what is the independent. Can you pause the video and think what is RT and what is pi t in our context? We want to know whether pi t is whether RT is Granger causing pi t. So here RT is what? RT is our independent variable. RT is our independent variable and pi t is our dependent variable. So this distinction matters a lot because that will give you the restricted and unrestricted equation. You have to form the restricted regression and the unrestricted regression because we want to know the restricted RSS and the unrestricted RSS. Remember that we have done this in the previous video. If you haven't watched that video, I'll give the link in the description and also in the iTab button. So please check that video out. That is absolutely necessary. Otherwise, you will not understand, right? So see here that RT is the independent variable and pi t is the dependent variable because we want to know whether RT influences pi t or not. So if we have this knowledge, what we can do, we can write the inflation equations. Since inflation is our dependent variable, we can write the inflation equations for both restricted and unrestricted format. So firstly, let me write the restricted one. Let me write the restricted form. This is step number 1 actually. So here, what will be the restriction? Restriction is that pi t only depends on its own lag values. If you remember under H naught, what we do, we say that there does not exist any Granger causality. It means that RT does not have that means RT does not have any bearing on pi t. That is what we are saying, which means that inflation depends only on its own lag values. And mathematically, if you write, it will be something like this. Pi t is alpha naught plus some alpha 1 and its own lag values only up to period 1, up to p equals to 1 and plus some error term. Plus some error term. So this basically means pi t, that is the inflation, depends only on its own lag values, which basically means that there is no Granger causality. And versus the unrestricted form. Versus we have the unrestricted form, which looks something like this. Again, the inflation equation. Here you have alpha naught plus alpha 1 pi t minus 1 plus some beta 1 RT minus 1. Up to period 1, the lag value of RT is included and some, say another term, say epsilon t. So this says that phi t depends on its own lags plus lagged interest rate plus the lagged interest rate. So this is what we have discussed also in our previous discussions, right? So you have two regression equations. These are the two regression equations where the restricted one follows H naught basically and the unrestricted one follows H1. Now you have to form the hypothesis. If you have these two regression equations, forming hypothesis is very simple now. Under H naught, what you know is that, what can you say? Under H1, under H naught, there is no, under H naught, you have no dependency, which means there is no Granger causality, which means that this RT minus 1 does not influence pi t, right? RT minus 1 does not influence pi t, which basically means the coefficient is statistically zero. Understand? The coefficient is statistically zero. This is the null hypothesis, and versus alternative is that beta 1 is not equals to 0. Beta 1 is not equals to 0. Or you can write in this fashion also, beta 1 can be, you can do the right tail test also or the left tail test. So that doesn't matter. So in general, you can do this, right? So H naught is that beta 1 is equals to 0 and H1 is beta 1 not equals to 0. So this is what we are going to test mathematically or test numerically. I hope this much is understandable. We have formed two regression equations, one for restricted, one for unrestricted, and then we have formalized that what will be the hypothesis that we want for our testing purposes, right? Now, what is the next step? The next step is that you have to fit these two regression equations. You have to fit these two regression equations. Now, for fitting them, you need some data. For fitting them, you need some sample data. So if you have some, data set from some source, that is well and good. Here I have taken an imaginary data set. This is not from any source. This is just a sample data. I have taken the values accordingly, right? This is not the actual official data, not taken from any particular source. So this is just imaginary example that I have given you so that you understand how to proceed in your actual situation. So suppose, see here, we have the time period. These are years. Time we have taken in years. So for years 1 to 10, see here, we have 10 years of data, 1 to 10. And for every year, we have taken the data of inflation and we have taken the data of interest rate. So inflation is 4 and 4 percentage points and interest rate is 5 percentage points and so on and so forth. For every year, we have taken certain values. Now, again, the question is the same, whether interest rate influences the inflation, basically. That is what we are trying to test. So for that, if you have this data set, you can fit these two regression models. This is simply the regression model. See here, you have the pi t and you have the lag values of pi t. And here you have the data set. All the pi values are given to you. So from so understand one thing, this t equals to 1 value will not be, of any use, because understand we have taken a bar 1 process. So for t equals to 1, if you want to fit the model, say pi 1, so what will that be? Alpha naught plus alpha 1, then the lag value, you will need some pi naught, right? You will need some pi naught and then you have some error term. Similarly, for the unrestricted one, you need, what is the coefficient I have taken? Okay, alpha naught. So alpha naught plus alpha 1 pi naught plus beta 1 r naught. So for fitting these two regressions for the time period t equals to 1, you need pi naught and r naught, which is not explicitly mentioned in our data. So this t equals to 1 will not be of any use. So essentially what we are saying, the usable observations are altogether 9. The usable observations are altogether 9, and there is a thumb rule for doing this. There is a thumb rule. So what we say usually is that, suppose the size, the total size is say 10, n equals to say 10. Here in our case, this is the case. We have total 10 points, 10 years basically. So n equals to 10. And what is the lag? What is the lag? The lag is 1. So the usable observation is simply 10 minus 1, 9. So you can use this for any context, right? This is in general. In general, this is the thumb rule. You have to eliminate the lag values. If p equals to 2, then it will be n minus 2. Then you will have 8 usable observations. And that is the same rule that we follow here. Right? So you have this data set. The first step is to fit the regression. Fit the regression. So let me write it down. From the restricted regression, you will fit the model and you will get, what is this? Okay, alpha naught. I have taken this to be alpha naught. So alpha naught cap plus alpha 1 cap pi t minus 1. And you can use any software. This is just simple two variable regression fitting. You can use the OLS method. You can use the OLS method to fit this. I have already done this. And what I have got is this. This will come out to be 0.5 plus 0.9 pi t minus 1. You can verify this. You can use any software to verify. This is just two variable regression fitting. I hope you can do this. And from the unrestricted model, unrestricted regression, you can again fit this using OLS. You will get pi t to be alpha naught. I should have taken some other, value. Any which ways, I hope you understand the process. After fitting, what you will get, once you fit this again using OLS, you can do this. This is multivariable fitting basically. Multivariable fitting. In Stata, it is just one line of code, reg, and then you take the variables. That is all you have to do. So pi t will come out to be, I have done this. This is 0.2, 0.6 pi t minus 1 plus 0.3 rt minus 1. This is based on the sample data that I have taken, that I have shown. You can pause the video, take a screenshot, and then use that sample data to verify this. And once you fit this, you not only get the fitted model, you also get the residual sum of square. So the residual sum of square for the restricted model will come out to be 0.45. You can check this, and residual sum of square for the unrestricted model will come out to be 0.26. Right? And if you remember, what was the test statistic? RSS of the, what was the thing? Let me check once. RSS of the restricted model minus RSS of the unrestricted model upon the degrees of freedom upon RSS of the unrestricted model upon n minus 2p minus 1. This was the computed test statistic. Now, if you see, we have all the data that we need for computing this test statistic. So, what is this RSSR? This is 0.45. 0.45 minus 0.20 upon P is simply 1 because we are fitting a var 1 process. And then this is this and usable observation. So see here, n equals to 9. This is something that you have to remember. N is not 10. Your usable observation is 9. So you have to take 9 here. 2 into 1 is 2 minus this. Now simply compute. If you compute this you will have something like this 0.0333, which will come out to be 7.5, which will come out to be 7.5. So if your if computed is simply 7.5, you can verify this. I'm not going step by step. You can simply check this whether I have done it correctly or not, right? Now comes the decision rule. This is the final part. For the decision rule, you have to know what is the critical value of f. So if you see f, the degrees of freedom is 1 and 6 and 0.05. You can take the right till test, or you can also do 0.025 if you are doing two till test. Doesn't matter. So it will come out to be approximately 5.99. So what we see here is that if computed, which was 7.5, is strictly greater than the F critical value. If computed is strictly greater than critical value, what does this mean? This simply means that we have to reject our H naught, which means we have to reject our H naught. And diagrammatically, if you see, if this is your distribution, so this is the critical value is 0.99, and your computed value lies somewhere here, 7.5. So we are in the rejection region, so we will reject it. Now, this is what we are saying here. And finally, what is the interpretation of all this? Let me write a short interpretation. Interpretation is as follows. The interest rate, Granger causes. Since we have rejected H naught, remember H naught means that there is no Granger causality. Since we have rejected that, interest rate, Granger causes inflation. Interest rate, Granger causes inflation, which basically means the lagged interest rate, significantly improves. The prediction of inflation rate. Prediction of inflation rate. So basically means that the past interest rate movements contains information which are statistically useful for predicting the information. So you can add that thing, that the past interest rate movements contains information useful, statistically useful for predicting the inflation rate. Right? So this is what is the interpretation of the entire thing that we have done so far. That interest rate does Granger cause the inflation, which basically means that the lagged interest rate, that is what is the key idea of Granger causality, that the lagged interest rate significantly improves. It gives some additional information. It contains some useful additional information that helps in the improvement in the prediction of the inflation rate. And that is why interest rate is Granger causing. We say that interest rate is Granger causing the inflation. So this is how you do it. And so this is the unidirectional causality that we have so far proved, that RT is Granger causing inflation. Now, if you want to test that pi t also Granger causes RT or not, you can do that using the reverse causality test. Exactly the same way, just giving you for your reference that if you want to know whether bidirectional causality exists or not. So what we do in that case, the independent and dependent variable will change. Now RT will become the dependent variable and phi t will become the independent variable. So this is RT minus 1 and then you will add the lag value of pi t minus 1. So basically you have to fit this regression model and then you have to test. You have to test whether this delta 1 is 0 or not. If the delta 1 is 0, you will say that no, there is no Granger causality. If it is not, you will say that yes, pi t also has Granger causality on the variable RT. So there are a few possible outcomes here. What could be the possible outcomes? What could be the possible outcomes? First outcome could be unidirectional causality. First is the unidirectional causality, which basically means that RT is Granger causing pi t, but pi t is not Granger causing RT. So we have already proved that RT is Granger causing pi t. But if you say that pi t is not Granger causing RT using this reverse causality test, you will say only the unidirectional causality exists. And it could be that bidirectional causality. It could be the bidirectional causality. It's very simple that RT is Granger causing pi t and pi t is also Granger causing RT. This can happen. And the third possibility, which is not possible in this case, but in some other scenario, you may face that reverse causality. Reverse causality. So if in some case you see that RT, that the example that you start off with is not Granger causing pi t, but pi t is Granger causing RT. So that will be the reverse causality. So here you have to decide which one is your target variable. Depending on that, you can say it is unidirectional or it is reverse causality, or it can be that there is no causality at all. The fourth possibility is no causality at all. No causality at all. That is, RT is not Granger causing pi t, and pi t is also not Granger causing RT. So these two variables are almost, independent. They are not influencing each other, or their lag values are not influencing their present behavior. So that is the case of no causality. So after you test the reverse causality, you may have these four possible outcomes. That is very interesting and that is very meaningful for the empirical work. So this method that I have told you is being used by empirical macroeconomists a lot. I know some of my colleagues and my friends who definitely use this Granger causality. So what could be the variables? They test the relationships like money supply and GDP, oil price and inflation, exchange rate, trade balance. So these are some of the key economic variables that can be tested, whether they are Granger causal or not. That can be very simply tested using this joint significant test or the S test that I have shown you. So they will use the official data from say World Bank or IMF, the official key variable data you can easily find out from the official websites of different sources. And using that, you can follow the similar steps that I have told you. So this example data set that I have given you, this is, as I've told you, this is imaginary. And originally you want to test as many years as you want. I have taken only 10 years just for your understanding. But in reality, you want to check decades and decades of data just to know the actual relationship among the variables, right? So this is what I wanted to share in this video. Let me do a quick recap that we wanted to know whether RT, that is the interest rate, is Granger causing the inflation rate or not. And we are in the setup of VAR1 system. Remember that we are in the setup of VAR1 system, which is also a very crucial assumption. And another assumption is that RT and pi t both are stationary. So these are the two inherent assumptions that we always keep in mind when we are applying the Granger causality thing, or we are testing the Granger causality thing. These are the important assumptions. And now you have to first decide which one is your target variable. We want to know that RT is Granger causing pi t or not. So pi t is the dependent variable or the target variable in the first case. and RT is the independent variable. So if you have that, for the dependent variable, you have to formulate two kinds of regression equation. First is the restricted one, the second is the unrestricted one. And these are the two regression equations that I have written here. You can see, you can take a screenshot if you want. And now you want to know whether this lag value of RT is influencing phi t. That is why you set this beta 1 to be equals to 0, which is your null hypothesis. If you see that you fail to reject the null hypothesis, which means that there is no Granger causality. RT is not Granger causing phi t. But if you reject H naught and you fail to reject the H1, that is beta 1 not equals to 0 or beta 1 greater than 0 or beta 1 say less than 0, whatever, one till test if you do, right till test, left till test if you do, or you do the two till test, doesn't matter. But whatever test you do, you will see, you can check that whether this is happening or not. And for that, for testing purposes, I have taken this data set. You can fit the regression models, the two regression models using the data set I have taken. And these will be the fitted regression and their corresponding RSS. And you can simply compute the statistic values. And as I've told you, as a thumb rule, the usable observations are simply the size, the data size. Here we have 10 years of data minus the total number of lags that you are using. So your usable N will be 9 instead of 10. So keep that into mind, that how you compute 10, how you compute this N value, and then the decision rule is pretty simple, right? So if your computed value exceeds the critical, you will say we reject H naught and you interpret your result in this particular fashion. So interpretation is very important. You can't just leave like this. You have to say, you have to clearly mention what you are getting and what is your conclusion after getting the result, right? And once you have the causality test, you can also do the reverse causality test, exactly just reversing the RT and phi t. The dependent variable will be independent and the independent will be dependent. And you will follow the exact same test that I have shown you to find out the required outcomes, whether there is only unidirectional causality, whether you have bidirectional, or you have reverse causality, or you have no causality at all, right? So this is what I wanted to share in today's video. I hope you like this video. This was one of the most requested videos on my channel. That is why I have made two different parts of it. And I have tried my best to explain to you in the best possible manner. I have also given you the numerical example to let you know how you actually do it using real data set. And if you like my endeavor, then do support my channel. Do give me a like and do subscribe to this channel, An Economist, because that gives me immense motivation to continue making such useful videos for you. It takes a lot of time and effort from my part to make them every single week. So if you like this, then do support my channel, right? So thank you so much for your time. In the next video, we will go into impulse response function, which is again a very, very crucial topic. And once we finish that, we will be done with the module 3 of our course, and then we will move to the module 4. That will be the final module. So this is the agenda for the next few videos. So stay tuned and thank you so much for your time.